Chapter 15, Problem 10. For the reaction A goes to products, the following data was collected. What is the concentration of A at 32.2 minutes? So since we're dealing with time, we want to know what's the equation of the line. However, we don't know what the order is just yet. Now there is something that's noteworthy. We could see that the concentration of A, as we go down in these increments, are going down by half. So that tells us that these are the times at which the half-life took place. Now, if we compare the difference here, that's 20 minutes. But then if we compare the difference here, that's only 10 minutes. And if we compare the difference here, that's only 5 minutes. So we should note that the half-lives decrease as the reaction progresses. So we learned that if that's the case, that's for zero order reactions. Now, the equation for the line, if we're talking about zero order, is concentration equals negative KT plus the initial concentration. But we don't know K. So how can we find K? Is we could either get the slope using the data points because K is related to the slope, but you can get K from half-lives. So the equation, if we want to use the half-life, is K equals the initial concentration of A over 2 times the half-life. So the initial concentration is 0.1. And since I used the first concentration, I have to use the first half-life, which is 20 minutes. So our constant ends up being 0.0025. Okay, now I have everything I need for the equation of the line. So negative K, so negative 0.0025. Our time is going to be 32.2 minutes. And the initial concentration is 0.1. This gives us a value of A to be 0.0195. Now, we kind of want to ask ourselves, is that reasonable if we can? So if we look, this value of A is somewhere in between 0.025 and 0.0125. And that kind of makes sense because 32.2 minutes is somewhere in between 30 and 35 minutes. So that's the logical answer.